In this video, we will do some examples of dividing polynomials using long division. I would suggest that you pause before each example, try it on your own, and then hit play to see what the answer becomes. Example 1, simplify. Now, because this is a polynomial divided by a monomial, I don't really have to worry about long division here. Simply, each part of the numerator has to be divided by the denominator. That can be represented as 60a squared b cubed over 12a b squared minus 48 b to the fourth over 12a b squared plus 84 a to the fifth b squared over 12a b squared. Then look at each monomial separately and simplify that one. 60 divided by 12 is 5. A squared divided by a is simply a. And b to the third divided by b squared is b. Minus 48 divided by 12 is 4. There is no a in the numerator, so the a in the denominator stays where it is. B to the fourth divided by b squared is b squared. Plus 84 divided by 12 is 7. A to the fifth divided by a is a to the fourth. And b squared divided by b squared is simply b. So this would be my final answer. Example 2, use long division to solve. First, set it up. X minus 3 outside. And then inside, since I'm starting with a quadratic term, make sure every term, every exponent is accounted for. Quadratic linear constant, so I'm okay there. Now, x needs to be multiplied by what to get rid of 2x squared? I would need to multiply by a 2x. Now, since 2x is linear, that has to go above the linear term inside the house. Then multiply your 2x through by your divisor. So I get 2x squared minus 6x. Now, be careful when you're subtracting. Here it's negative 5 minus a negative 6, so I simply get x. Now, bring down the minus 3, and then I look at x needs to be multiplied by what to get rid of x? Well, that would just be simply 1. That gets multiplied through. When I subtract, I end up with 0. So my final answer is simply 2x plus 1, no remainder. Example 3. P to the third minus 6 divided by p minus 1. When I set it up, I'm starting with p cubed, so that means I need 0p squared. I also need 0p and then minus 6. You need to include the square term and your constant term. Now, p has to get multiplied by what to get rid of p cubed? Well, I would need a p squared. So multiply p squared throughout. So I get p cubed minus p squared. And I subtract that. 0 minus a negative 1 is simply just p squared. Bring down plus 0p. P has to get multiplied by what to get rid of p squared? That would just be plus p. Multiply your p throughout. So I get p squared minus p. Subtract that. I end up with 1p. Bring down your minus 6. P has to get multiplied by what to get rid of 1p? I just need a plus 1. Multiply throughout. I get 1p minus 1. Subtract them. I get negative 6 minus a negative 1, which is really negative 5. So then my final, this becomes my remainder. So that has to go over what I was dividing by. So my final answer is p squared plus p plus 1 minus 5 over p minus 1. Now it's a minus 5 because the 5 was negative. Last example, use long division to solve 2x cubed minus 5x squared plus 4x minus 4 divided by x minus 2. When we go to set it up, x minus 2, 2x cubed minus 5x squared plus 4x minus 4. Every term is accounted for, so I don't need any placeholders. So x has to get multiplied by what to get rid of 2x cubed? Well, I would need a 2x squared. Multiply that throughout. So I get 2x cubed minus 4x squared. When I do the subtraction, I end up with negative x squared. Now bring down plus 4x. So I end up with what needs to get multiplied by my x to get rid of negative x squared. I'm going to need a negative x. So multiply that throughout. I end up with plus 2x minus x squared. Do the subtraction, and I have 2x. Bring down your minus 4. So what needs to be multiplied by x to get rid of 2x? That would be plus 2. Multiply that throughout. After doing the subtraction, I get 0. So my final answer is 2x squared minus x plus 2. Hopefully these examples help with long division.